Meiosis is a process of nucleus cell division that occurs in sex cells which produce 4 daughter haploid gamete cells from a single parent diploid cell. These cells contain half the genetic information of the parent cell and are contained as DNA. They allow for future organisms to adapt to external environments and ensure the passing of genetic material to offspring. Meiosis occurs in 2 stages, meiosis 1 and meiosis 2. In the case of meiosis, the chromosome number embodies the 23rd sex chromosome. Late interphase 1 is where centrioles duplicate to form 2 centrosomes which extend microtubules that will form the meiotic spindle. Prophase 1 follows, where the process of synapsis that allows for the chromatin to condense and form homologous pairs of sister chromatids. The process of crossing over, also known as recombination, is an exchange of DNA between segments of non-sister chromatids, thus increasing the genetic diversity. The process finishes with the breakdown of nuclear membrane as the centrioles move to the opposite ends of the cell, when with the centrosome organizing and extending, spindle fibers connecting in the centromere. Metaphase 1 begins as the chromosomes align in the center on the metaphase pair after centrioles locate themselves on opposite poles of the cell and allow for spindle fibers to connect to the kinetochore. During anaphase 1, the homologous pairs are separated by being pulled apart towards the opposite poles by the centrosome, which allow for the sister chromatids to remain together. The cell then enters telophase 1 when chromosomes decondense at the opposite poles and the nuclear membrane forms. Meiosis 1 finalizes with cytokinesis 1, where the cell separates into 2 haploid daughter cells and the genetic material becomes uncondensed. In prophase 2, the nuclear membrane dissolves and the centrioles duplicate and move towards opposite poles as the chromatin condenses to form chromosomes. Metaphase 2, the chromosomes again line up against the metaphase plate and become attached to the meiotic spindle fibers. Anaphase 2 concludes as chromosomes are pulled apart to the opposite poles of the cell. In telophase 2, sister chromatids reach opposite ends of the pole and the nuclear membrane forms, known as segregation, where 2 sister chromatids are separated and move to the opposite poles of the nucleus. Finally, in cytokinesis 2, the cell divides into 4 haploid daughter cells, all very genetically different, thus ensuring the continuity of a species.